equal to C1 e to the lambda x minus, right, ut is something like this one, t e to the lambda x, this one. Okay, if you solve this one, you can have this one. Normally, it's like this one, okay, you can remember, you don't have to learn, you can remember this form, okay. Okay, so the other one, see, this one is repeated group, right? So you have this one. If your independent variable is x, you have this one, right? This one. Okay. So, for example, this one. Example, right? This one you have eigenvalue, distinct eigenvalue, right? So your solution will be combination of this right? Okay, this eigenvalue will be 3 and 4, right? Okay, this one similar, right? This one we have contradicted, right? Root of this one compared to this one. So in this case, you have you have this term and this term, right? So this term is 2 over e, right? This one. And this one will be this one, right? 6, right? Sine cos. C1 and C2 can be found from initial condition, right? Okay? Or it can be written this one. Okay, something like this one can be also. Okay. Okay. This one as well. Okay. This one repeat. You have this one. Right. Okay. Okay. So you have this initial condition. You can substitute and find solution. Okay. Another form that for example, you have this one. Let's say you have this system, right? So your dynamic model is this one, right? This one, right? If you substitute y equal to e to the lambda t in this case to this one, you have this equation, characteristic equation. This equation. Okay, and root of this one will be imaginary. So term alpha is 0, so you have this one sine cosine, right? This one. If you have this one, let's see, second order as well. Let's see, look at this one. Remember this one, right? Let's say we have f here. X here, right? Equilibrium position, right? This one, right? So in this case, we have this one, right? This one, sorry. Okay, you have this one. K, C, right? M, X here. So you have M X double dot plus C X dot plus K X, right? This one, summation M equal to M X equal to M, sorry, equal to F, right? This one. Right? So you have this one, C over M, X dot, plus K over M, X equal to 1 over M, F, right? This one. One of the form that you will see in the future many times. You have this one, this form. You have this form. Okay. You see, this one can convert to this form, right? See? You can convert this one to this form. For example, omega n equal to square root k over n, right? See, omega n equal to this one. If you want to convert this one to this form, this one is very important form. You will see a lot in the future, right? You have this one, okay, and you have these 2 sine omega n equal to c omega n, c over n, right? This one, right? And look at this one. If you have sine equal to c over this one, 2 omega n, right? This one, okay? Okay, and this one is we call c sub c is 2 omega n m, right? See, you can write this one, right? Or see, if you substitute this one, square root k over m multiplied by m, right? So this one is 2 square root mk, right? This one. Okay, this one. See, you have this one, right? You have this form. You have to remember this form anyway. Okay, equal to this one, you see. So c sub c we call critical damping. Critical damping. You see, and you look at this one. See, this one we call damping ratio, damping factor or ratio, size is damping factor or ratio is equal to c over c sub c. Okay, c over c sub c, right? C sub c is this one. Okay, and in this one we call this one called natural frequency. Natural frequency. Natural frequency. Okay, this one. Right? This one called natural frequency, right? Size is damping factor is equal to c over c sub c, right? This one. Okay, and look at this one. It's very important anyway, this one, for physical, right? You see, one thing that you need to remember this one, I mean, you need to understand about this one is like, look at this natural frequency. If f this one input, right, and has same frequency, see omega n. If this one you apply force has same frequency omega n, what happened to this one? อันนี้เคยถามคำถาม this one is for exact meter exact this one you can understand okay what happened have you ever see the video have you ever seen the video of the I mean, let's see Skyline. I mean, not Skyline. Saitama. See, certain amount, let's say. Okay? See? You know why they fail? Just this one first. This the bridge, Tacoma Beach. Tacoma Beach. Right, we have this one. Have you been here? Wind hit. Let's say the beach. Okay. See? You see the way the wind hit is frequency, right? Right? See this, we can see, right? If this frequency equal to this frequency, it will start what? Like this. Boom. That's a Tacoma Beach in Indiana. That's a classic problem for vibration. Okay? Similar to this one is a tower, let's say. If you have this building and you have earthquake, how it check? You know how it check. เฮ้ยคุณยังไม่ต้องทำบ้านนั่นหรอกคุณฟังผมดีกว่าเชื่อผมฟังผมดีกว่าเชื่อผมฟังผมดีกว่าเดี๋ยวคุณทำเนี่ยไปเดี๋ยวก็สอบผมออกมาอย่างนี้คุณไม่รู้เรื่องคุณโอเค look at this one you see when you have earthquake you have this vibration right start this one every rigid body not rigid body every structure has their own natural frequency every structure has their own natural frequency you see this structure this one as well right they have their own natural frequency okay in this case this one is natural frequency okay next semester you study with me you have to answer this one for control okay if f is frequency is equal to this one you check and stable similar to that one this one and that one they do have many natural frequency they do have many natural frequency okay we call mode shape okay so if this one hit the frequency is equal to one of the frequency of this one actually low frequency the main one okay you will check it out stop similar to that one as well if this one equal to natural frequency of that one okay so it's down if you want to prevent this one from natural frequency how can you design you have to make it more rigid right if you make it more rigid the natural frequency will be very high will be very high and this one is not that high enough to meet that one okay so it's not broke anyway okay so because of the design less rigid than should be in that case you see the natural frequency will low and will go down anyway okay so this one this for second order system as I mentioned right this one is not in the lecture this one is not in the PowerPoint you have to record it yourself it's not in okay so look at this one you see this one, if you have this problem, let's say, if you have this problem, let's see. Okay, you have this problem, this one. Okay. Okay. Okay, let's see. You have to lecture by yourself this one, huh? If you remember me, my style, if I say this one will be in the exam, it will be, right? So you need to lecture this one by yourself, or test your ability to record. Okay? This one will be in the exam. Definitely 99%. Left just 1%, maybe I forgot it to put in the exam. Okay? And if you have some initial condition, and if you have some initial condition, let's say you have spring here, initial condition, right? You see, a spring here, I place the initial condition, right? Right? If I release my hand, what it should be? สมมติว่าเรากดไปนะ I place, okay? I place in this one. Okay, I place here. I place here. Right, we have this one. This is the initial condition. Right, this one. Is if you release your hand, what it should be? X. Can it be this one? Can it be this one? Can it be this one? Which one? Can you tell from that equation? Can you tell?
Either one or two.
Can you tell? Huh? No way, you cannot tell. Right? I didn't give you any number of MCK, right? Look at this one, you have eigenvalue here. You have eigenvalue. How many eigenvalue you have? 2 eigenvalue. Right? 2 eigenvalue. Okay? It can be two distinct, right? It can be two repeated root, right? Right? Can be two repeated root. It can be what? Complex conjugate. Complex conjugate. Right? Right? So you look at this one, there are 3 types of this one. Similar to this one, right? Similar to this one. There are 3 cases here. Case number 1. Right? Root of it, right? Case number 2. And case number 3. Okay? There are 3 cases, right? Okay? And look at this one. How come you can tell which one is this ludicrous, right? So you need to find what? Root of this one, right? You need to find this one. You have changed this one to this form. I'll change this one to this one. X dot K over M X M F. If we do just initial condition, this means that in homogeneous solution, right? We don't have this one, right? Not that one. So you need to find root of this one, right? In this case, you have lambda square, right? This one, lambda square plus C over M, lambda plus K over M, right? If we assume E equal to lambda T, right? In this case, equal to 0, right? See? Right? You have this one. Okay? So, look at this one. So you have to find root of this one. It can be over there, that one, right? This one, right? Okay? But if I convert this one, if I convert this one to this one, X double dot, convert this one to X dot X. Let's say I convert this one to this one. Convert this one to this one. Okay? See? Is damping, this one with damping factor, right? Damping ratio factor, right? If this one less than 1, greater than 0, right? Greater than 1, go to 1. This one, let's see. Okay, similar, right? This one, you can find root, right? You can find root, right? Okay, if I written this one, you have the root of this one is omega n plus 1 sine square minus 1, right? Omega n, right? This one. Root of this one, lambda 1 and lambda 2, right? This one, minus b, right? B a square minus 4ac, a square, right? Okay, you have this one. Okay, this one. Right? If this one, root of this one will be this one, right? Right? This one will be this one. You have two of them, right? If lambda, this one sine, let's say equal to 1, what happens? If sine equal to 1, you have two repeated root, which is 0. So if this one equals to 0, it's two repeated root. Two repeated root. Right? If sine greater than 1, you have two distinct roots, right? Greater than 1, two distinct roots. Right? If sine equal to 1, sorry, this one, sorry, not equal to 1. If sine less than 1, this is less than 1, you have what? Complex conjugate, right? Complex conjugate. So if you have equation over there, that one, right? You have equation there, over there. And if you can find sine, right? So you have MC, right? Previously we just gave you this. Right. This one. You see? You can start, you can find sine here. You know C, you know M. You know omega M, right? And you can start find sine here, right? So if sine greater than 1, what happens? Is sine greater than 1. What happens? Maybe like this. Like this. No oscillation. Okay? Like this. Similar to this one as well. Maybe like this as well. Like this as well. Only this one compared to again. You have sine and cosine, right? This one. It will be this one. Right? It will be this one. Remember, this one, you see, you have this. If you are in compact conjugate, you have this one, right? You have this one. See, you have this one. As I mentioned, this one can be written this form. E to the alpha x cos beta x plus base. Right, this one. So it's something like this one. Let's say it's alpha minus. You have this one. Right, this term. Cos is something like this one. Right? If you multiply these two together, you're gonna have this one. Right? This one. Right? Right, both of them. You have this one. See, so look at this equation. See, you have this one. Okay? Okay. Okay. So now is it possible to be this one? Is it possible to be this one? You have any Is it possible? Is it possible to be this one? Why?อะไรคือ real life ว่าจริงๆอะไร real life Is it possible to be this one? Look at this one. Look at this one. Okay. If you add, you place x0. If you place x0, okay? If you place x0, it means that you put potential E there, right? ใช่ไหม Right? If you release, that potential will be released, right? Convert to kinetic energy, right? ใช่ปะ Right? If I don't have this one, I don't have damper. If you place and you release, it will never stop, right? Because ideal spring store energy, right? And it change from potential energy to kinetic energy, change from potential to kinetic energy. So you will not stop, right? Okay, you have to try to write this paragraph, by yourself, because you have to explain in the exam. Okay? I told you already, right? This will be in exam. Okay? Right? If I add this one, right? You have this release. Okay? Because of C is dissipate the heat. C dissipate the heat. Right? Okay? This dissipate the heat anyway. Okay? That's why you see this one. Okay? So actually, look at this one. If you want to see this, you want to make sure, you want to prove that this one, see, you want to make sure, first of all, you have this one, right? Let's see, you have F here. Right, you have mx double dot. Let me put this way. X double dot plus c over m x dot plus k over m f over m, right? This one. This one. See? And you have solution, right? This one. X double dot plus c over m x dot plus k over m equal to 0. Let's see homogeneous first. Okay? And this one, you can written this form, right? This one. X dot. X dot. X equal to 0, right? You can, the solution of this one will be this one, right? If this one less than 1, right? Your solution will be this one, right? Right? X equal to what? C1 E2 what? This one. Yeah. Omega D, this one. Actually, you have this one is equal to omega n 1 minus square. You solve this one. Right? You have characteristic equation, right? What is the characteristic equation for this one? This one is lambda square plus 2 sine omega n, right? And lambda plus k over n. Omega, sorry, this one. Omega n square. Omega n square, right? This one. So you have this one. N lambda plus omega n square, right? This one, characteristic equation, this one. Right? 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 See, okay? So you have this one. If you see see, root of this one will be, as I mentioned before, right? Okay. If lambda less than 1. If lambda less than 1, you have this solution. Right? See?
ตรง K ของข้างบนสุดมันก็มี x ด้วยใช่ไหม
อะไรนะ
K ของข้างบนสุดนะครับมี x
เนี่ยตรงไหน
ตรงนั้นครับ
ทำไมอ่ะ K over M X sorry good if we have this one we have this solution right okay so in this case you see the solution will be this form right this one will be this form this one, right, will be this one, right? Right? Or will be this one, right? You have this one, right? And this one, if alpha is minus, similarly this one, it is minus. See? It is minus. Sorry, we have t here as well. T. Right. So, if this one, you see, t go infinity, this one will be 0, right? Right? If t over infinity, this one will be 0. Okay? So actually this one, if you have c over there in that case, it will be 0. So it means it's stable. Right? Right? You place and you release. Right? It's stable, right? Right? Or if lambda, this one, if lambda, this one, greater than 1, two distinct root, right? You have this one, you have this solution, this one. Right? So it's something like this one, you place and you release,